Welcome to our Chapter 6, Section 5 video. This is still talking about binomial distributions like we were last time, but this time we're calculating probabilities using the normal curve. So it's titled Normal Approximations of Binomial Distributions. So binomial distributions, remember, like distributions is like you're listing out all the different outcomes and their probabilities. So when we deal with binomial distribution, this would be like if we had listed out all the different outcomes that we could have, how many successes, so like from 0, 1 success, 2 successes, 3, all the way up to whatever your number of trials n is, and then listed out their probabilities underneath. So that would be the binomial distribution. If we were to graph it out using a histogram or something like that, then we could be able to look at the shape of it, stuff like that. So without actually having to graph things out, because, we're lazy. So if p is close to 0.5, then the shape of this distribution is actually always going to be roughly symmetric. Whenever p is less than 0.5, so p being our probability of success, then it's going to be skewed right. And if p is greater than 0.5, then it'd be the opposite, skewed left. Sometimes when we're finding our probabilities, rather than trying to use binom PDF or binom CDF, we can also use the normal curve to approximate this. This works the best when you have giant numbers, because in real life most of the time you're going to have giant numbers in terms of dealing with a lot of people, a lot of number trials, things like that. So the normal curve is easier to approximate because sometimes our calculator gets overloaded. If we use too big of numbers, our calculator can only do so much. So that's why the normal curve sometimes is good to use as well. So it only works sometimes though because it is an approximation. So there's rules for when we can use the normal curve. In order for the normal curve to work, n times p has to be greater than 10 and n times 1 minus p also has to be greater than 10. So if only one of these is greater than 10, then it doesn't work. So if we check for this next example, we have a survey of 500 U.S. teenagers. Subjects were asked a variety of questions about their personal finance. One question asked whether the teen had a debit card. Suppose that exactly 12% of teens have debit cards. So that right there, our P, our probability of success. We're letting x be the number of teens in a random sample of size 500, so there's our n, who have a debit card. Is the probability distribution of x approximately normal? Justify your answer. So here we're being asked, can we even use the normal curve? So to check, we're going to check n times p and n times 1 minus p and see if when I multiply things out, is it a number greater than 10? So in this problem, we said n equals 500 and p equals 0.12. So when I multiply that out, 500 times 0.12 is going to give me 60. That's a number that's greater than 10. We also have to check n times 1 minus p. So 500 times 1 minus 0.12, which is 0.88, gives me 440. Both of those numbers are greater than 10, so this is approximately normal. Okay, so now that we know it's approximately normal, then we know that for something like this, we can use the normal curve to calculate probabilities. So we're going to do just that. Using the information from the previous example, use the normal distribution to calculate the probability that at most 50 teens in the sample will have debit cards. So if we're going to use the normal curve, remember we always have to label the mean and the standard deviation on it. So that's something we got to find first. Just a quick reminder, from last section we had formulas for the mean and standard deviation. So for the mean, the formula was n times p. When we do n times p, we get 60. For the standard deviation, the formula was this one with the square root of n times p times 1 minus p. So plugging in all our numbers, we get 7.2664. So now I can label this on my normal curve. So we're going to label the middle with our mean. Alright, it's really hard to draw on this computer, but here we go. Here is the middle of a mean is 60, and the standard deviation I labeled with 7.2664. In this question, it was asking us to calculate the probability that at most 50 teens in the sample will have debit cards. So at most means 50 is the max, anything smaller is what we want. So we're going to shade this in on our graph as well. So here's my beautiful drawing. Here's 50. We're shading to the left because it's asking for at most. So now we're doing our probability the same way that we had before. So we're calculating our z-score using our table to find the probability. So z-score first. Remember, your z-score formula is take your value that they're being asked about minus the mean divided by the standard deviation. When we do that, we get negative 1.38 if I round to 2 decimal places. Remember, using your table, you always want 2 decimal places because your table only tells you z-scores up to 2 decimal places. All right, then looking at our table, we're looking for the z-score of negative 1.38. So scrolling down, we're on the negative side here, negative 1.38 would be the 0.0838. And since our area is shaded to the left, this is the easiest type of probability to find because anything to the left, that is our answer. There's nothing else that we have to do to it. So we found that the probability that at most 50 teens in the sample will have debit cards is about 8.38%. Okay, so let's take a look at another example. This time we're doing like a full problem. The probability of a randomly selected person in the US having type O blood is about 45%. Suppose a sample of 25 people are randomly selected. Can you use the normal distribution to calculate the probability that less than 10 people of the people selected have type O blood? If so, find the probability. If not, use the binomial formula to find the probability. So here, this is how we do it. Like, if you can't use the normal curve, then you have to go back to using either binom PDF or binom CDF in order to calculate your probabilities. But if we can use the normal curve, then we can do so. So to check first, in this problem, we have n equals 25, and P is going to be the percentage of type O blood, which is 45%. So checking to see if we can actually use the normal distribution, we would have to check n times P and n times 1 minus P. So when I check, n times P is 11.25, which is just barely over 10, but that is still going to work. And then n times 1 minus P is 13.75, which also works. So we know the normal curve will work here. So if we know the normal curve will work here, let's draw our normal curve, find the mean and standard deviation, find the z-score, find the probability. I've done some quick math for you. The mean ends up being 11.25 because n times P, which we just did. The standard deviation, we have our formula. Plugging everything in, we get 2.4875. So from here, let's label our mean and standard deviation on the normal curve. And then in this problem, we're looking for the probability that less than 10 people selected have type O blood. So labeling 10 on our graph and then shading, since it's less than, we're going to shade to the left. There's our beautiful picture. Next, we're finding z-score and then finding the probability. So plugging into the z-score formula, I get 10 minus the mean of 11.25 divided by our standard deviation of 2.4875. That comes out to negative 0.50 when I round to 2 decimal places. So looking at my table again, our first decimal place is negative 0.5. So it'll be all the way down here. Negative 0.50 would be this one right here. And again, it's shaded to the left, so that is our final answer, 0.3085. In other words, the probability that less than 10 people of the people selected have type O blood is going to be about 30.85%. Okay, let's pretend in this situation, let's pretend that the n times P, n times 1 minus P wasn't greater than 10, and we couldn't use the normal curve. In this case, then we would have to use binom CDF because we're dealing with less than 10. Less than 10 would mean we want people like 9 and below. Remember, it starts at 0, so we're adding up all the probabilities from 0 up until 9, not including the 10. So since we're adding things up, we would use binom CDF. I'm just going to put this on the side here. If your normal curve doesn't work, use binom CDF to add up all of our probabilities together. So in this case, n would be 25. The probability of success is 0.45. And we wanted to add all the way up until 9 for us, since we wanted the probability that was less than 10, so we don't include the 10. And then do that in your calculator. Since it's a less than problem, we don't have anything to subtract from 1 for. So that would be it. All right, so now we have all the different ways to find probabilities of binomial random variables, and that's the end of this chapter. Thanks for watching.